And you know what? I think it'll be a lot of fun for us to now go through and try to model this together using Onshape. And who knows, maybe I'll beat some of these wizards and I'll come out with my answer first. So let's get into it here. We're going to start by going to tootalltoby.com. We're going to log in with a free account, and then we're going to access the full library. And once we access the full library, we're going to see that up at the top here, we've got these special challenges. See, this library has over 190 challenges. And you can filter these results by your current available capability, meaning the tier level of difficulty. You could say, I only want to see tier 1 challenges. These are going to be pretty simple challenges here, or I want to see only tier 3 challenges. You can kind of work your way up. But until you sign up for Practice Models Premium, you're not going to have access to the entire library, but what you can do is kind of preview that Practice Models Premium functionality by doing one of these featured challenges. And today we're going to do this challenge here. Over on the left, we see in the chat that some of our participants in Model Monday Live are doing the same challenge. So let's get into it here. We're going to say click here to practice. And we can see here that this challenge is going to be using some sheet metal, maybe using the hole tool or the slot tool, and it's going to be using symmetry. So I'm going to say click here to begin and go. So what is the mass of this part in XXXX grams? And we're going to try to enter that mass right here in this answer box. And wow, this is a pretty cool sheet metal model here. So what I like to do before I actually get started with the challenge is I like to just kind of take a moment and come up with a game plan. So I'm going to click this button here that says open in new window. And I'm just going to kind of look over this challenge before I actually jump into Onshape. And I'm just going to try to come up with a game plan of how I'm going to model this. Now, what I really like about this particular challenge is that this gives us a chance in Onshape to use some cool sheet metal functionality, including the convert to sheet metal functionality. And it really goes to show that if you know your tools, if you've gone through the free Onshape training for sheet metal and you've learned a little bit about the difference between sheet metal extrude and sheet metal convert, you'll start to realize this might be a good candidate for the convert option. And that's exactly what we're going to end up using here as we attempt to create this model. So we're also going to talk about how to model just half of this model using Onshape and some considerations you might make if you're intending to mirror this model later on. Some considerations you might make with your layout geometry and some considerations you might make with your dimensioning strategy. So I think that with all that being said, instead of describing what I'm going to do, I'm just going to jump right into Onshape and do it. I think that my first sketch is going to look like this. Going to look like this shape here. It's actually going to have this little notch here in the corner, and my origin is going to be right down here at this intersection between 100 millimeters and 180 millimeters. So if you're following along with as part of this tutorial, that's how kind of how I think I would start. And so let me move this over to my second screen. Let me bring up Onshape here. I'm going to bring up my keyboard cam as well so that you can see all of the keyboard shortcuts I'm using as we go through this tutorial. And let's get into it here in Onshape. Now I am using the free version of Onshape, onshape.com/free. So if you want to, you can log into Onshape and then you can search the public repository for this file name, and then you'll be able to find my version of this file. So I'm going to say create document, and I'm going to call this 25-07-03 SM keyhole bracket. And let's say create public document. And then the first thing I'm going to do is I'm going to look down in the corner of the drawing and recognize that the unit system is millimeters. So I'm just going to go down here to workspace units from this hamburger menu up top. And I'm going to say the workspace units should be millimeters. The mass should be in grams. They're already set to that because that's in my profile. So I'm ready to move on here. So now I'm going to go front plane, S key, begin a sketch, N key to get normal to, S key, and I'm going to begin a line. I'm going to start here at the origin, single click, move my mouse over, single click, let go of my mouse, and I'm going to type in 180, enter. And then I'm going to move my mouse straight up here, single click, let go of my mouse, 15, enter. Going to move my mouse up at an angle here, single click, move my mouse over, single click, and then move my mouse back down to the origin, single click, let go of my mouse, and I'm going to type in 100. Now I'm going to press the S key and create a dimension here. From this angled line to this lower line here, that is going to be an angle of 30. And then finally, I'm going to press the S key and I'm going to create a rectangle here from the origin. I'm going to come up like so. I'm going to single click and let go of my mouse, and I'm going to type in 10, enter, and then I'm going to type in 35 plus 4, enter. And so what that gives me is it gives me this kind of profile shape here that we're seeing in the front view, coming over, coming up, coming over, coming up like so. And we're going to see in a moment how we can really leverage that shape as part of the sheet metal convert functionality in Onshape. Now, normally when I do my Onshape tutorials, I do my Onshapes. Normally when I do my Onshape tutorials, I do my tutorials by using the sheet metal flange or the sheet metal extrude function. So I'm kind of trying to mix it up a little bit here, but I'm also trying to remind you that when you learn Onshape, when you learn sheet metal, you really want to take care to learn some of the other tools because they could save you a lot of time and a lot of frustration and maybe give you some new options to create your sheet metal designs. So today we're going to use the convert function for sheet metal. And that means that the first thing we're going to do is just extrude this. So S key extrude. I'm going to press the space bar. That clears my selections because it got the entire shape. And then I'll just click in this region here so that I can maintain that little notch. And I'm going to bring this out to a depth of 160/2. So I'm only going to bring this out to half of the distance. Now, one way that we could control what's going on from that end view would be to work with layout geometry. And what I mean by that is we could maybe come in here to this right side plane, S key, begin a sketch, S key, create a line, single click, move our mouse over in this direction, single click, 160, enter. And then we could hit escape, pick the origin, pick this line, and then shift M. And what that does is it drops at 160 on the midpoint. And this is a nice technique to use as you get into more and more complicated designs where you can input the geometry that you are going to be using as its full length. So like the gap here in the middle of this part is a gap of 7. So I could put in this gap here and then I could take this line and this point here and shift M and drop that on there. And then we can use this geometry a little bit later. This sketch would be like our end view layout for symmetry. We'll call it something like that. End view layout for symmetry. So we rename this sketch here. Now that's our end view layout for symmetry. Now, where can we use that in our design process? Well, where we could use it is we could do S key extrude, and then we could click on this shape here, extrude it out as a solid, and then we could say up to entity or up to vertex, and we could pick this vertex here in our layout sketch. So now if we want to change, if the customer comes to us and says, hey, what's the current width of that? Well, we could double click here on this sketch and we could say, oh, it's 160. Oh, well, I want to the customer wants to change that to 220. Well, instead of having to recalculate with typing in 220 over 2, we could just double click here and change that to 220. And sometimes when the customer is doing a design review with you, they appreciate this. They appreciate that it's not like a confusing, weird equation thing. It's just, here's the number, 220, change it to 160, and then the geometry updates and it's 160. In the end, it'll be 160 when we mirror it. So like I said at the beginning in this tutorial, what I'm trying to do is show you some different techniques you can use when you're modeling using symmetry at the end of the model so that you can utilize the whole numbers as you're going through and actually creating the model. So if that sounds good to you, if you like that, hit the like button on this video and let's continue on here with this design. Now, again, taking advantage of this idea of using convert to sheet metal, what we could do at this point is we could begin a sketch here. So S key, begin a sketch, and then we could take that layout geometry that we had created earlier. So here's that end view for layout geometry, and we could use that geometry to construct a rectangle here. And for that rectangle, what we could do is we could do S key extrude, and this could be a remove, and it doesn't really matter what the depth is here. We could even just leave it, the way it's shown there, or we could have that extrude go the full length. It really doesn't matter. I'm just going to make it through all just to kind of really show you that it doesn't matter what that length is. But what does matter is that we're picking up on this point here, which is dimensioned at 7 millimeters for the total gap with a midpoint relationship here. We use Shift M for that midpoint relationship. Now, the reason that's significant is because when we get to our next step, convert, we're going to be using this geometry. So let's just finish that extrusion. There you go. You see that might look a little bit strange, but as you do more and more of the sheet metal conversion tool, you'll realize you'll be able to more rapidly visualize what the solid shape should look like. So now I'm going to click the sheet metal model. And I'm going to choose the option for convert. And here it says pick a part or surfaces to convert. So I'm just going to pick anywhere on the solid. It doesn't matter where I pick. So I'll just pick here on the solid. It doesn't really matter. And then what I can do is I can say faces to exclude. And the faces that I'm going to exclude are going to be this face here, this face here. I'm going to exclude this face here. I'm going to exclude this face here, exclude this face here. I'm going to exclude this face here, and this face here. Now, again, that might seem a little bit cumbersome or a little bit confusing, but like I said, this will become more and more second nature the more you practice it. But now what I've set myself up to do is say here, edges or cylinders to bend. Now I can simply pick this corner here from the original solid and this corner here from the original solid, and look at that. That's looking a lot like our sheet metal design. That's looking pretty darn good, I think. So what we've seen here is that by utilizing this convert to sheet metal, we've really saved ourselves a lot of time, or, you know, really maybe not that much time, but we've really given ourselves kind of a new technique that we can use when we're working in sheet metal. Instead of doing it using a series of flanges, we could do it using a solid model and then just do a convert to sheet metal, or a sheet metal convert option. So I'm going to go to a top view here, and what I'm really trying to look at is this is the line that should be held, and the material here you can see is going too far. And we could also see that if we look at this thing from a front view. So this is the line that's supposed to be held, but here we see the material is going beyond that line. So we have to remember to say that for our thickness, we want that thickness to be going the other direction. So make sure your thickness is going in the correct direction. And then on the drawing, it says that the thickness should be 4 millimeters, tab, and the wall thickness should be, or the radius should be 6 millimeters, tab. And look at that. This thing is looking great. So that is exactly what we wanted, and that is how we're going to start this sheet metal process. We hit the green check mark, and boom, there we go. Now, this doesn't mean that we need to exclusively use convert. A lot of times you use convert to get the first sheet, but then you go back through and add in your regular sheet metal features like flange, and I'll pick this edge here, and we're going to bring a flange up. And now, once again, I'll go into a standard view, so shift 1 to get into a front view, and this flange really should be over here. Should be all the way over here. So we need to adjust our flange alignment. So inner, outer, middle, it's going to be hold line. Hold line means that the flange, the bend begins right here where the original geometry existed. So hold line, there we go. That flange comes right up to that point. And then for the height of this flange, well, the height of this flange is based on a 4 millimeter gap. So let's create this using the option here for end type up to entity with offset. And we'll say it's going to come right up to this face here. However, it's going to have an offset of 4 millimeters. And there we go. There is our 4 millimeter gap in that flange. So now we've got all the solid geometry. Now we're ready to go through and add some of our cuts. So for the first cut here, we'll pick this face, S key, begin a sketch, N key to get normal to. And what I really like about this sketch is it's a great reminder of kind of waking up the geometry from the model. So what I mean by that is I'm going to begin the line command. I'm going to click out here kind of anywhere. I'm going to move down here. And then if parallel doesn't work, just put your mouse over this edge here, and then move back down, and now look at that, now parallel does work. And so we could click down here, we could move over in this direction. Now I want this one to be exactly vertical to this point here. I want it to be exactly vertical, but I'm not getting vertical. Again, hold your mouse over the geometry, come back down here, and now look at that. Now I can get exactly vertical. And then I can move my mouse back up here and click here to close off that sketch. S key, dimension, create a dimension here from this line to this line, 14, a dimension from here to here at 24, and a dimension from the bottom here to here, again at 24. S key, fillet, and we'll drop in a fillet here, here, and here. And then you can click in the background to finish those fillets, and then you can type in the radius of those fillets, 7, enter, and there we go. There's that shape. S key, extrude, and this I could just rip through all. Remove, it's sheet metal, so it defaults to remove through all. Boom, done with that one. Now for our slot, so this face here, we want to again remember that the eventual goal of this thing is to be symmetric. So I'm going to pick this face here, S key, begin a sketch, N key to get normal to, and I'm just going to drop a point here on this edge somewhere arbitrarily, not at the midpoint, but maybe like here. And then I'm going to S key line, and I'm going to drop in a line here and make that line midpoint to that point. So take this line, take this point, Shift M, make that midpoint. S key, add a dimension here to that line. I could have added that dimension when I was creating it. That dimension is going to be 92. That's center to center for our slot. And then I'm going to hit escape, click on that line, and then S key. I have the slot command in my S key menu. So S key slot, and this slot is going to have a diameter of 12. And there we go. And then we're going to S key dimension and create a dimension here from the base up to this lower edge of the slot. And that dimension is going to be 16. And so now we've got that slot in there, again, accounting for the symmetry that we anticipate from mirroring this thing at the end. So S key extrude, remove through all, punch that slot through the back. And now for our final shape, we could just draw this entire shape here the way it's shown in our top view. So pick this face here, S key, begin a sketch, N key, get normal to, S key, create a circle, single click along this edge, not at the midpoint, but just somewhere along this edge. Just watch out you don't get the midpoint. Single click and then let go of your mouse, 90, enter. We can S key here, create a rectangle like so, hit escape, pick this line here, pick the center point of your circle, Shift M for midpoint, S key, dimension. The width of this one is going to be 30. The distance from the nose is going to be 30. And then finally, the distance from the back of the part to the center of our hole here is going to be 80. And once we have that geometry, S key extrude, and that's going to be removed through all, and boom, there's that shape. And now it's just a matter of mirroring. So we go here to mirror. We say we're going to mirror this entire part. It's going to be an add. Make sure you pick add there. Sometimes that gets me in sheet metal and I end up with two separate parts. So we're going to mirror that. We're going to pick this face here to mirror about. Just pick this face here to mirror about. Mirror the entire part, add, mirror it about that face, and hit the green check mark. And there we go. There is our sheet metal model in Onshape. We can press P to hide our planes. There's still some sketches shown here, so we can use Shift P to hide all of our reference geometry. We can come over here to our sheet metal table and flat view and just kind of look at this thing, and we see that it looks a lot like the flat pattern for reference in the drawing. So I think that is a win. So we can close out of that view as well. We can come over here to the name of the part at the bottom of the tree here, and we can say edit appearance, and we can make this look a little bit more like what the customer gave us. The customers always like it when you model the parts and then change the color to look like their actual parts. It's a great way to get repeat business. So there we go. That's looking a lot like the customer part. And then we can finish off here by right clicking on the name of the part, and we can say here, assign material. And this material is going to come from the Too Tall Toby custom material library. And so I do have a tutorial on how to create that material library. I'll include a link to that down below in the description. But here you can see we are going to take this and we are going to assign a material of plain carbon steel, hit the green check mark, and then the final step in this challenge is just to click down here on our little mass property icon. And our mass property for this part is coming out at 1427 grams. So let's go back here into our practice models app and let's see how close we got. 1488 and enter. Oh, incorrect. 1488 is not correct. So once in a while, I just like to test it to make sure that the validation is still working. So 1427 and enter. And oh yeah, congratulations. We got it correct. And so if you enjoyed that tutorial, be sure to hit the like button on this video. And of course, if you haven't had a chance yet, be sure to visit us at tootalltoby.com so that you can continue to practice your 3D CAD skills. You can continue to practice and improve your 3D CAD skills. So let's submit this answer. We got it in 1646. And then the cool thing about the app is that we are now able to go down here into our first 42. And we can see who was able to finish this model the fastest from the time it was released. So this was released at 1:35, and at 13:40, at 1:40 p.m., Victor K, the world champion of 3D CAD speed modeling, came in with an answer just 4 minutes and 26 seconds after it was released. Congratulations to Victor K. He will earn the second point in today's episode of Model Monday Live. But we got to give a huge shout out to Dom, because I noticed here that as I was coming in, Dom has not only finished here in the first 42, but he's already posted a recording of himself finishing this model. And it looks like he was able to finish it in just 3 minutes and 27 seconds. It took me 16 minutes to finish it. Dom did it in 3 minutes and 27 seconds. And you can click on this link here to watch his video. of that run. So that is awesome, Dom. Thank you so much. I love it. I love it. And thank you so much for doing that. Not only finishing in the first 42, but also submitting a speed running video for the community to watch. That is so cool. So guys, this is an awesome leaderboard here. We got to give a shout out here to Victor, CSWP Victor, CSWE Victor, Dom, Rambros, Matab coming in here in 4th with 6 minutes. We got Gray coming in here in 5th, Perkins from Ireland coming in 6th, Libe coming in from Venezuela.